Okay, class, we're back now, and we're looking at response to change in stimulus strength. Now, this has to do with spatial summation. Spatial summation. Okay, adding extra motor units. Adding extra motor units. So, let's start. All right. Where we are, if we increase the stimulus strength coming from the spinal cord, we will start to increase the number of motor units. Each motor unit, as you recall, has a certain number of muscle cells, muscle fibers. Recruitment is when we add extra motor units. The more motor units you add in your muscle, the more muscle fibers you activate, the stronger the contraction. The stronger, that doesn't take a great genius. So the more you activate, the stronger the contraction. Okay? So we go here. You activated one motor unit. Now you have two working. You recruited the second one. Now you recruited the third. If the third is all you had, if you only had three, then you got the strongest contraction. Let's go back to my example. Okay? That means entire muscle has 10 motor units. So if you recruited all 10, you could lift 50 pounds using my hypothetical situation. If you only had one motor unit, if you only had one, and the entire and each motor unit has 20 muscles, then you would have had what? Just 5. So so in other words, 5, then you increase another one, 10, then you increase another one. So using my hypothetical, you can see what I'm talking about. Okay? So that's what we call recruitment. That's what we call a spatial summation. A spatial summation. All right, let's move to another topic. Okay? What we're talking about now is going to be what we're going to call muscle tone, tonus. Now, what is tonus? Resting muscle tension. Resting what? Muscle tension. So tonus is resting muscle tension. Now, let's think, why do you want some? So, in other words, right now I'm sitting in a chair. I'm not using my biceps. Let's say right now, not lifting anything. But if I feel on my biceps, there's a certain amount of tension on my biceps, even though I consider them relaxed. Even though I consider them relaxed. That tension, while my biceps is rested, is called the tonus. Now, if we look at just everyday language, when you touch somebody or you feel their arm, you say, "Oh, you feel firm. You must be working out." That's their tonus. Let's say they're not trying to contract their arm, but you push on it. Why? By them working out, their muscle cells, each cell has gotten bigger. See, now here's another thing. Skeletal muscle cells, after you're very young, in your early childhood, they don't really increase. Skeletal muscle cells don't do mitosis after you're quite young, 6, 7, so forth like that. So then how does your arm get bigger if you're working out? The cells themselves get bigger. You start putting more actin and myosin in there. Why do you get stronger when you work out lifting weights? Because why do they tell you you need to take in amino acids? Because what you're trying to do is increase the amount of contractile components, the actin and myosin. The more actin and myosin pulling, the stronger the muscle cell. The more actin and myosin pulling. But this tonus is a resting muscle tension. Then you say, well, why do you need tonus? Okay, we're in class. Somebody runs in with a gun, which I hate to say it like that in this day and time. You're going to be nervous and you're going to be ready to try to get out of there or do something. If your muscle cells were totally flaccid, it would take too long to go from totally no contraction at all to full contraction to run. It would just take too long. So if your muscles will say are already in a partially tightened state, then you could do something. So we need a certain amount of resting muscle tension. All right. The question comes, what allows us to have tonus? Okay. Interspersed within a muscle are these things right here we'll just bring up. And these are called muscle spindles. These right here are called muscle spindles. Now listen to me. There, you see that spiral ending right there? There is a certain amount of stretch on this spiral, on these muscle spindles. Certain amount of stretch. If the muscle, which right here, started to get too loose, relax too much, this would elongate. Now see, there's a normal length on these. Now let's think about it. There's a normal length. If the muscle started to relax, this would lengthen. It would inform these nerves here go to your spinal cord. It would inform the spinal cord, these are sensory nerves, that your muscle is getting too relaxed. It would inform the spinal cord your muscles are getting too relaxed. So then what will happen, the spinal cord will send a signal to this and to your muscles to tighten up. So in other words, muscle spindles start to stretch too much, muscle too tight. Too loose, muscle too loose. Signal goes to spinal cord sends signal back to tighten up. I don't know how many of you have ever had a doctor's visit and they hit your knee with a hammer to look at your reflexes. Now what happens, you hit the patellar tendon. It's called the patellar tendon reflex. We'll talk about it in nerves. When you hit the patellar tendon, that puts a quick jerk on your anterior thigh muscles, the quads. The muscle spindle in the quads thinks that it's relaxing too much because but hitting that tendon, it pulled on it. So it sends a quick signal to the spinal cord. Spinal cord sends the signal back. The muscle contracts and your lower leg pops out. Knee jerk. So in other words, these muscle spindles do that. Now here we go with something else. Listen to me. Right here, this muscle is attached to the bone by a tendon. Now let's think about that. This muscle is attached to the bone by a tendon. So we got the tendon and we got the muscle. All right. If your muscle was to contract too much, get too tight and shorten, if your muscle was to contract too much, get too tight and shorten, tighten and shorten, it could potentially pull the muscle tendon and the tendon would pull off the bone. We call it an avulsion. When you pull something away, it's called an avulsion. A-V-U-L-S-I-O-N. So if this muscle was to tighten too much, it could potentially pull the tendon off of the bone it's attached to. An avulsion. Okay? So we need another signaler. And this is called the Golgi tendon organ. The Golgi tendon organ is working diametrically opposite to the muscle spindle. When the Golgi tendon organ senses that the tendon is getting too tight, it will send a signal through sensory fiber to the spinal cord and tell the muscle to relax some. So we got two opposite forces happening here. This right here is holding tonus, but we don't want our muscles to get so tight they pull off the bone. So hopefully you can see what I'm saying in that particular scenario. All right? All right. So we go from there now to this here, isotonic contractions, isometric. I think what I'm going to do is start a separate video for this one. Okay, thank you.